Good morning, everybody out there in Mathland. Today we will be doing the last lesson in Chapter 12, which is problem solving with perimeter and area. In other words, these will be word problems that we will have to figure out using our formulas for perimeter and area. This lesson starts on page 593, but I'm actually going to go ahead and start on page 594. Now, usually, this way to solve the problem is very overwhelming just because it takes so much space. So I am actually going to start by solving the problem up here and just working it out wherever I have space. So here we go. A rectangular board has an area of 1,700 square inches. Right there. You cut out a rectangular piece that is 10 inches long and 9 inches wide to make a carnival prop similar to the one shown. What is the area of the prop? Okay, so we know that the area of the rectangular board is 1,700. We know that they are cutting out, you cut a rectangular piece that is 10 inches long and 9 inches wide to make carnival props similar to the one shown. What is the area of the prop? Okay, so that means that we have to figure out what the rectangular piece that we cut off was and subtracted from the area of the whole thing to know what's the final area of the figure. So here it is. Let's see how much this piece, 10 inches long and 9 inches wide, is. So the formula for area is length times width. So the length is 10 inches. The width is 9 inches. That means the area of that piece that they cut out is 90 square inches. Now we have to figure out what the rest of the board now is. So we knew it was 1,700, but it's missing this. So since that piece has been cut out, we have to eliminate it from 1,700. Let's take away the 90. See, it was cut off. So 0 minus 0 is 0. I can now take 9 away from 0, so I make the 7 a 6 and make this a 10. 10 minus 9 is 1. 6 minus nothing is 6. 1 minus nothing is 1. So that means that the final answer, the area of that big prop, is 1,610 square inches because they cut off that little part from 1,700. Okay. On the bottom right here, it says, how can you check whether your answer above is reasonable? Where? Well, if you take the 1,610 and add the 90 that they cut off, we should get 1,700 square inches, which is what the problem told us was the area of the rectangular board that they used. See, 1,700, so we are correct. All right, so let's move on to the problems on this page, okay? We're gonna do them patiently. I'm gonna try to explain them as best as I can so that you can follow along, okay? Here we go. A construction worker has 40 feet of caution tape. Is this enough tape to surround a rectangular region that is 120 inches long and 90 inches wide? So, 40 feet, is it enough to surround a rectangular region? That means that they want to go around a shape. If we are talking about the outside of a shape, that is what? Perimeter, not area. So we know that he has 40 feet. So is 40 feet going to be enough to go around 120 inches and 90 inches wide? So here's a rectangular region, 120 inches long, 90 inches wide, right? Now for perimeter, we know that the formula is perimeter equals 2 times the length plus 2 times the width. Hold on. I'm so sorry. Now my sneezes are forever on YouTube. So 2 times the length, that is 2 times 120 plus 2 times 90, which is the width, okay? So now perimeter equals 2 times 120, that's 240, plus 2 times 90, that's 180, okay? So now I need to add those two up. I'm actually going to use the space up here to add 240, 180. I'm going to add 0, 12 carry 1. This is 420. So 420 inches, not square inches because we're not talking about area, we're talking about perimeter. Now we need to see if that's enough. Well, the answer is 40 feet and this is in inches. That means that we have to convert 40 feet to inches to see if I have enough. So to convert that 40 feet to inches, in 1 foot there's 12 inches. So what is 12 times 40? So 40 times 12. That is actually, hold on. We can actually use a trick that I've taught you guys before. If this is 0, you just put a 0 down here and then just do 4 times 12, which is 48. So you have 480 inches of tape using 40 feet, but you only need 420 to go around this entire shape. So do you have, is this enough tape? Yes, because 480 inches is more than the 420 inches that you actually need. Okay, moving right along. And I am gonna actually erase these little things over here just so that I can have the room for this problem. 1 ton of salt de-ices a rectangular section of a road that is 10,500 meters long and 3 meters wide. How many square meters does 6 tons of salt de-ice? So, let's see. Rectangular section on the road. How many square meters does? So, a rectangular section of a road. So we're talking about area because we have to de-ice the entire road. What de-icing means is that in very cold states, when it snows and stuff like that, the road freezes and that's really dangerous to drive on it. So what they do is they use salt because salt makes that ice and that snow melt so that it can be safer for people to drive. So that rectangular section of the road is 10,500 meters long and 3 meters wide. Okay, so 1 ton of salt de-ices a rectangular section of road that is that much. How many square meters does the 6 tons of salt de-ice? Because they said square meters, that means that they want area. So I have to multiply these two numbers together. 10,500 times 3. 3 times 0, 0. 3 times 0, 0. 3 times 5, 15. Carry 1. 3 times 0, 0. Plus 1 is 1. 3 times 1, 3. So 31,500. So the area of this thing is 31,500 square meters. That is what 1 ton does. So if this is what 1 ton does, how can we figure out how much 6 tons is gonna do? That means that I need to multiply this number times 6. 0, 0, 30 carry 3. 6 times 1 is 6 plus 3 is 9. 3 times 6, 18. So that means that 6 tons of salt can de-ice 189,000 square meters. That's the final answer. Okay, understand the problem, then make a plan. We're gonna solve it, okay? Here we go. A worker installs fencing around 2 rectangular properties. Right off the bat, fences that goes around the outside of a property, meaning that this is perimeter we're talking about. And there's 2 different rectangular properties. One is 99 feet long and 80 feet wide. So let's draw. So one is 99 feet long and 80 feet wide. The other is 95 feet long and 83 feet wide. Which property requires more fencing and how much more fencing do you need? So that means that we need to calculate the perimeter for this one, calculate the perimeter for that one, and then subtract them from each other because it says how much more, okay? So I don't have a lot of space to work these problems out right there. So I'm actually gonna take an extra piece of paper to do those calculations, okay? So this one was 99 feet and 80 feet. The other one was 95 feet and 83 feet. Okay, So which property requires more fencing? So here we go. Perimeter for both of these shapes. Let's start here. Perimeter equals 2 times the length plus 2 times the width. Perimeter then would be 2 times 99, which is the length, plus 2 times 80, which is the width. 99 times 2, that's 198. Plus 2 times 80, that's 160. When adding those two together, I'm going to do it right here, 198, 160, 8, 15, 1, 358 feet. Not square feet, because square feet would be area, and I'm doing perimeter. Now let's figure out this guy. So perimeter, we know that is 2 times the length plus 2 times the width. So 2 times 95, because that's the length, plus 2 times 83, because that's the width. Okay, 2 times 95. So if we know that 2 times 90 is 180, and then 2 times 5 is 10, that means 190. Plus 83, so 80 and 80 is 160, 160 plus 6, because that's what 2 times 3 is, that's 166. I used a distributive property to do that in my head, but there's no shame on doing it on your side of your paper either. In fact, I'll demonstrate it right now. 95 times 2, 10 carry 1, 2 times 9 is 18, plus 1 is 19, so there's that one. And 2 times 83, so 83 times 2, 2 times 3 is 6, 2 times 8 is 16. See, 166, 190. Now we add those two numbers up. We get 6, 5, 1, 3. So that means that the perimeter of this one is 356 feet. So which one of the rectangular ones requires more fencing? This one requires more fencing, so the first one. And then by how much more? Well, this one was 358, and this one was 356, so 2 feet more of fencing. There we go. Okay, number 5. A roofer covers the rectangular roof with shingles. A chimney occupies a rectangular area that is 4 feet long and 2 feet wide. How many square feet of the roof are with shingles? So that means that I need to figure out the whole roof and then subtract this little area of the chimney, which won't need the shingles. So area, right? Rectangular area. That means length times width. Area equals length times width. I don't know why I put parentheses around that. It's not necessary. Let me do that again. Length times width. So area equals 60 times 30. 6 times 3 is 18 with 2 zeros. Pew, pew. So that means the area of the roof is 1,800 square feet. Now it says that the chimney is 4 feet long times 2 feet wide. 4 feet long, 2 feet wide. So length times width. 4 feet long, 2 feet wide. That means it's 8. So I need to subtract the 8 feet away from 1,800. So 1,800 minus the 8 feet. Again, oh, I'm so sorry. I can now borrow from this guy or this guy, so make this guy a 7. This guy really is a 10, but really a 9. And then this is a 10. 10 minus 8 is 2. 9 minus nothing is 9. 7 minus nothing is 7. 1 minus nothing is. So square feet. How many square feet of the roof are with shingles? 1,792 square feet. Okay, last problem of this page. You want to buy a cover for the lid of your laptop. Your laptop is 1 1/3 feet long and 1 foot wide. Which cover will fit best on your laptop? So there's this cover, and this cover. Your laptop is 1 1/3 feet long times 1 foot wide. That's the area that you want to cover, right? Now, in order to multiply this, this is in feet. and the answers are in inches. So we can either convert these to inches and then figure it out, or multiply this out and then convert the answer to inches, sorry. So what I'm gonna do is I'm gonna take 1 1/3 feet and convert it to inches. Okay, because this 1 foot, that's easy. That's already 12 inches. There's only 1 foot. So this one, 1 1/3. First we start with a whole number. 1 times 12, that's 12 feet so far, and 1/3 of 12. So that means if I divided this 12 by 3, I only have one of those parts. So that's 12 divided by 3. That would be 4. So only 4 feet. That's 16 inches. So area would be 16 inches times 12 inches. I'm going to multiply those out. 16 times 12. I didn't clear the trash. There we go. That's 192 inches. So this covers 192 inches. This is 126 3/4, and this is, or 3/4, and this is 159 1/2. 192 inches. This one's exactly 192 inches. That cover would fit it best. Awesome. So now, last two problems. Sometimes the figures that you want to, the area that you want to figure out is something called a complex shape, which means it's more than one shape pressed together. So I have to figure out the area that way. So we're going to be patient in how we're going to do this. Don't worry, I'm going to help you. You want to install new carpet in the rectangular bedroom and the rectangular closet. How much carpet do you need to cover the floor? So how much carpet, like how many feet of carpet would you need to cover that floor for both the bedroom and that closet? So that means that we need to figure out the area of the bedroom, because the carpet's on the inside, not the outside. Area of the bedroom and the closet. So I'm going to start with bedroom. Area formula is length times width. The length of the bedroom is 20 feet. The width of the bedroom is 10 feet. That's an area of 200 square feet. Now the closet. Length times width. The length of the closet is 10 feet. The width is 4 feet. That'd be 40 square feet. Now, if we want to know how much for both of them, then we just add those two numbers together. So you need 240 square feet of carpeting to cover the whole thing. Last problem. A gardener wants to enclose the garden with fencing. Ooh, fencing. That means that I need to go around the outside. The garden is in the shape of 2 rectangles. How much fencing does the gardener need? Okay, here's what's interesting, ladies and gentlemen. You don't need necessarily to figure out the perimeter for this one and then the perimeter for this one, because this shape is actually all together. So we have to figure out how to add up all these sides. Now, here's what's tricky. We know how much this side is. We know how much that side is. We know how much this side is and this side. But we are missing how much this is right here on this side and this side right here. The way we figure it out is actually pretty simple. This side measures the same thing as this side and this side combined. Because if you were going to move this line over here, it would be the same exact size as this thing. So if this little piece is 3, but the whole thing is 6, that means that you're missing another 3 yards. Because 3 and 3 equals 6. So this little side right here is 3. Now we need to figure out this guy right here on the bottom. Well, if this whole side is 10 yards, and this little side right here is only 8, this line and this line combined would also equal 10 yards. So if you already have 8, 10 minus 8, this little piece is 2 yards. So now I have to come over here and add all these numbers up. 10 plus 6 plus 8 plus 3 plus 2 plus 3 in order to know the perimeter all around, all those yards. 10 plus 6 is 16. 8 plus 3 is 11. 2 plus 3 is 6. So now, oh, hold on a minute. I want to make sure I do this. Oh, I'm so sorry. Not multiplication. Addition, Ms. Rivera. So that's 5. Okay. So 16 plus 11, that's 27. 27 plus 5 equals 32 yards. So he needs 32 yards of fencing to go all around that shape. Okay, so I want you to do this homework online. I want you to be very careful with your calculations. Please remember to have an adult submit, check your work before you submit it. That's very important. Let me know if you have any questions, and have a good day. Bye-bye.